Hey dudes, I figured I'd break these two kind of videos down so you could watch them separately rather than scrubbing through them. So this one's just going to be a recording on the p5.js lecture 4B. This is going to get over kind of like the nitty gritty bits of code organization, kind of giving you a better introduction in how we're going to be setting stuff up and how we're using our code. Some of it might be a little strange to you guys. This is why it's helpful to make sure that you've read through that reading that I gave you, which is going to be more or less similar topics that I'm covering right now. But, reading it at your own pace, then pairing it with this, then we're going to, the next video will be part one of an in-depth exercise. And we're just going to start kind of compounding pieces together. So I just finished converting this, and I have my presenter notes on my phone, so we'll just see how this goes. So I'm just going to maximize this and play. And this should be pretty good. So yeah, this is going to be kind of giving us the rough fundamentals of coding if you have not coded before. And specifically, this is in context to p5.js. Just getting hang on. There we go. Switching on my phone. So P5 is a follow-up to processing, and I've mentioned processing quite a few times. I've used it every semester so far that I've taught at UB, and where processing was Java based, JavaScript is the form of P5, and because it's JavaScript, we have the ability to plop it right in a browser window and be able to play around with it. The one main point here, though, is it's not directly JavaScript. It's like a sub-library of JavaScript, right? So it does, our files do have like a file structure, like a file hierarchy that is kind of like behind the scenes, which I'll talk about here in this lecture as well. So yeah, the really nice thing about processing in P5 is that it's very visual, and it's a lot easier to grasp than traditional means. I have gone through the traditional before at an earlier stage. Giving you context, I think I was learning in community college HTML3, so kind of starting to get dated here. But there's a very pleasing cause-effect relationship to processing that you've already probably gotten a little taste of. So P5, yeah, uses vector data. We can move things around on screen, but we also have the ability of putting in images. So I have mentioned before that we've done, processing, or we've done Photoshop and Illustrator and Audacity, and processing P5 is kind of a way to combine all of those with active input to alter how things are affecting one another, hence interactivity. So we do have a lot of different things we could discover and play around with. I don't plan on showing you guys all of these different routes to be taking. I try to just introduce you to the main core concepts and what some of the stuff that's out there I just mentioned or it's on screen. But it's going to be your job to make sure you're, keeping a notepad out and jotting down, anything to then research and follow up with on your own time. Somebody did ask me about like network communication with other programs. Totally available. I have not done it myself. I've done other network communication between different programs, but not P5. So, if you're at that point, I'd totally be down to kind of help you research and build that out. And then as well as if you've coded before, like if you've taken DMS121, you've gone through that process of learning object-oriented programming, which, for those of you who have not heard this term, it's basically that sense of constructing an object inside of code. So whatever you want to compile into an object, it's very kind of abstract to kind of wrap your head around. The easiest way to kind of learn more would be to just check out Daniel Schiffman's videos once you're at that point. But most people in the class, if you haven't coded before, you won't be getting into any of the object orientation in this class. But if you have done it, I'm not going to say it's a requirement to do, but you really should take that opportunity to continue on with those skills and make sure you're keeping them current and using this as another excuse to, build a portfolio piece potentially. So we already kind of talked about this, using a grid system. We do have the ability of accessing the z-axis for like 3D. Unless you've coded before, I really wouldn't dive into that. I haven't very much myself either. It's just a matter of, finding the appropriate research and tackling it. But for all intents and purposes, 2D is plenty for the intro course here. Weird. In the middle of my lecture, my notes on my phone are an old version, so might be a little bumpy here, so I apologize. So functions here, they're kind of, this is going to be a slight bit confusion here because, and I don't know the reasoning why. I'm thinking maybe there's references out there that talk more in depth about it, but here where it says in yellow function, like function setup, function draw, these are just establishing keywords that P5 uses to understand that there's going to be a new block of code. And by block, we're of course referring to how there's starting curly brackets and an ending curly brackets, like on line 1 and line 4. So any kind of block of code is basic, for what you're going to be dealing with in this class anyways, and what I've encountered is going to be dealing with this function. In processing, it would be void, like void setup, void draw, which is a little easier to talk about. But anyway, that's what function is visually, as you can read it there. It's just establishing a block of code. So the function setup is a block of code that runs once. So it's executing anything you need to happen one time, like loading in an image, setting the canvas, and so forth. So there's some stuff that you could put in setup that could also have gone in draw. Just depends on if you want it to be ran multiple times or one time. So it's just kind of like an easy access port of entry there. So yeah, again, draw is looping continuously, and I'll talk a little bit more about other components of that. So this is getting into the confusion here. So functions are predefined operations or instructions, and by functions, I'm not referring to the yellow text in the sketch window there, or in the code window. I'm referring to the cyan colored components, like on line 7, line 8, line 9. All of those end with a semicolon. These are all operations. They are called functions. So that's why I say it's a little bit of a bummer that they called what you see in yellow as function as well. But anywho, it's just terminology. The point here is kind of getting you primed in like what these different pieces of code are. And so these different functions, like on 7, 8, 9 that I just was saying, they're all going to start out the same way. It's going to have a call word, right? That function name or the operation name, like stroke. It's always going to have a starting parenthesis and an end parenthesis, and then that semicolon. The semicolon is optional nowadays, but it's good to still keep up with that. So everything inside of the parentheses is actually, like I said, predefined, meaning it's based on that particular operation. So stroke will always have the option of having 3 digits, separated by commas, so 3 different inputs, or a 4th, right? Because you could have transparency or an alpha channel. So it all just depends on what the function is, and that's why it's really nice to have the reference page to be able to go through this. So I usually get some questions on this piece here, but as soon as we start diving into the code a little bit more on Monday, it should be a little bit easier to get a sense of, and then we can ask some questions then. So beyond that general setup of like the coding components that we have that we're going to be accessing and changing and implementing our concepts into, the top left of the sketch also has a little arrow, and it's collapsed by default, but if you click it, you pop that open, and on the side you'll see sketch files with the different library components that are needed to run this particular sketch. And I'm pretty sure we covered this, but sketch by sketch I mean program. P5 calls them sketches. So this is where you could also add other sketch files if you wanted to have multiple sketch files that you're referencing. Or you also could add a folder, and you all will be adding a folder here. Usually it's just in the form of calling it a folder called assets, and then you just put in all your photos or audio files in that folder. And that way when you're calling stuff, it's all kind of centralized. You don't have this big clutter mess on the side. Should have not let my phone go to sleep. So this is the one big thing to note that I just discovered the other day, is that your particular account for P5, it has a maximum storage capacity on the browser on your account of 250 megs, which is a quarter of a gig. So you do have to make sure that if your project's going to be very like image intensive, or if you're planning on having multiple different projects on one account, it's probably going to be wise to use Photoshop to make sure you're setting dimensions, but then also saving for web. So somebody asked me, like, what file size should we be, if we have a background image that we want to load or whatever. I've been saying it's probably decent enough just to do 1080p, 1920 by 1080 pixels, because a lot of screens support that now. It's I would say it's the standard more so, but we can zoom in, zoom out on the web, so it's not really a big deal. But I wouldn't really be going larger than that unless you want like really high fidelity down the road. I only say this because you can have smaller file sizes if you keep your resolution down. So we have different primitives. We've already kind of went over a few different ones the other day, like rectangle. I threw in triangle, but you could actually draw stuff in here, like vector, like a pen tool in Illustrator. One second. It turned off my notes for a second. I thought I didn't have any notes for this page. Continuing. And like I mentioned before, all of these different functions have their own specifications, like how many digits you could be putting in. The other thing that was mentioned the other day is spacing within your code. So you'll see like after a line, there's several spaces, whereas triangle and point, they have no space, like before the parentheses. That doesn't matter. It's all just based on preference, and most of the time you'll just default to using like the tidy up function, which is Command Tab for Mac. That way we can all read things a lot easier. So we do have different drawing attributes. These are all, again, listed on the reference page, so I won't go in depth here. Variables. This is one of the big tier components. So the way, I just realized this right now, I think the way that I've learned to describe this for newcomers to code, which I should have listed at the beginning of this presentation, there's like three big main components of coding that you should be focusing on. So one of them is just organization. So you'll just have to know that there are these different blocks like setup and draw. Being able to comment your code, right? Different ways of organizing, and how to put functions in where. The second big component of this code to dive into here with to understand is variables. Variables are, you could basically remember them as a container, like a glass holds water, right? How much water in a percentage wise? Well, depends on how much is in there, right? We could dump some out, we could pour some more in. So that container can hold a value, and we can assign whatever value we want to that container. And what's nice is, as we go along, if we want, say, a rectangle to be updating itself, we don't have to manually stop the code, go in, change the value, right? Similar to how we were using mouse X and mouse Y. Those are variables that are known by P5 already, but we can set our own as well. And so the most common that we're going to be dealing with the most are variables, which is just condensed to var, var. These are integer values or whole numbers. They should be. I don't think they could be floating numbers. Somebody can let me know if I'm wrong on that, but they're usually used for global, being a global variable. And this is the somewhat tricky part, even though it doesn't quite matter right now, and I'll go over it in the exercise. I guess the bigger thing to grasp onto here is like, well, what are these variables? How can I use them, right? So I will just note that there are a few different types here, such as floating values if you need to use decimals, or some guides you go over, they might have a decimal being used. Or if you have any data coming in from like a sensor, those traditionally are going to be in decimal form because it's analog data, which has more of a constant flow, and so it never has that strict integer value. Some people like to use booleans, like either true or false, like off, on, like a switch. I personally just like to use a variable and just have like 0 or 1, because later on, if I choose I want to have more than just off or on, then I have that ability. So this is the example page that might hopefully help you make sense of what a variable is. So for the most part, variables, you will be declaring them outside of setup and outside of draw. And by outside, I mean like they're not within the brackets of either of those two blocks of code. And you can see this because they're aligned left, like they're aligned the same level as that function setup block, whereas the content inside that function setup is tabbed over, right? So you can always see based on the alignment where things are, what's inside of other content. So by having them outside of setup or draw, they're what I just referred to as global variables, meaning if you set them up here, usually it's best to just have it above, like at the top of your code. This way we all like have a good sense of where everything is. If you set this up here, later on down in draw or setup, if you access the variable like score, then the program will know what that is, because it's a globalized variable, not a localized. A local variable would be like if you were to declare these variables inside of setup or inside of draw. But here we're declaring them outside of them, so therefore they're global. So you can see we just declare each one by typing var, right? We're saying there is going to be a variable. What is the variable? Oh, the variable is perfect, and that's the name of the variable. We can set a name. And then we could also set a value, an initial value to that name. or to this variable container. So the word perfect is now equal to 23. So anywhere that we could put a number now, we could put the word perfect, all lowercase, like it's spelled there, and that would be equal to 23. We could also just put in a variable like x. X is also just a name, so that's kind of a confusing thing to try to figure out when you first learning code. Is a lot of people default to using like x and y and such, but it's really just a name. You could be naming anything you want in certain areas. So in that instance, that variable x doesn't have a value. It's not declared right there with the naming of this variable. So therefore, it defaults to 0. So then there's also this other variable called perfect score with a capital S, and that is set with an initial value to equal the variable perfect plus the variable score, right? So in this first case, the value of perfect score is going to be 100. It's going to do that math for us. I can't remember if I changed anything or not on this. So later on, if we were to, update the value of perfect to something else, obviously that would update the perfect score as well, and that would change with that, it would reflect that change. Yeah, all of my notes here are from my old lecture. That's so weird. Must be a lag on the iCloud server. It's weird because the title is correct, but everything else is old. So I'm just kind of winging it here. Variable names can only include letters, numbers, and underscores. You can't start a name with a number. All of them, everything in the code is case sensitive, including variable names. And this bottom part here is something that you all should get in the habit of doing. This way, you don't use one way one time and then another way another time. If you have like a variable that has multiple names, right? And you would do this so you can remember what that variable's for, right? Something that's accurate for that description. Instead of player 1 as the name, all lowercase, you would have player lowercase, but then the subsequent words would have a capital for the first letter, right? So you can kind of read it a little clearer. And that's just the way a lot of people go through and organize or set up their code. So if we're all following the same guidelines, it'll be helpful. So here you can start to get into the third and final component of coding that I want you guys to be focusing on for this course. And if you're new to coding. And this is going to be conditional statements. So conditional statements are basically like doing math. And based on the outcome of that math, we're going to execute something or we're not going to execute something. So it's basically like asking a question, doing some math. If that question equates to true, then we're going to execute whatever's happening. So down on line 12, this is our first setup of a conditional statement. And you can see that it's inside of the function draw block. And it starts off just by if and parentheses. and the name perfect score, which is already a variable that we already declared at the top on line 4, right? So since we already declared what that is, P5 already knows that value, right? And that value is 100. So in this case, if the perfect score, which is 100, if 100 is equal to the value of, two equal signs is equating something, not equaling. We'll get more into that in a moment. If it's equal to the value of 100, then we have starting brackets and ending bracket, and then everything in between those brackets will be executed if that condition is true. And in this case, it is as of the start of this code, which means that line 13 is going to be executed on a loop, right? Because draw is looping. And what's happening on line 13 is we're using this conditional statement to update a value of a different variable. So you can see on line 13 that x is now being assigned a new value, x equals x plus 1. So right now, you can see on line 2 that we did declare x, so that means we can use it down below. And x is 0 by default. So by default on line 13, the first time we see x, that's going to be the value of 0. But now we're going to assign a new value of it to x. And what's the current value of x? 0 plus 1. So 0 plus 1 is 1. So after that line of code is read, line 13, x is now equal to 1. And then our code goes down and reads 14, 15, 16. That's it. And so it starts back up at the top again of line 10. And that goes back down. And perfect score is still 100. So therefore, we're going to execute line 13 again. Now, x is equal to 1. So we're assigning a new value of x again. And this time it's going to be 1 plus 1, which is 2. So each time 13 is being read, we're increasing the value of itself by 1, right? And we can see here in this example that on line 11, the background color is the value of x. And because x is moving, is updating itself, that color of that background is also going to change. So it's going to start off with a value of black, 0, and it's going to go all the way up to white, right? Eventually this x will keep adding to itself, and it'll eventually get to 255, which is the whitest white we can get, right? So then that prompts a question like, well, what happens after that, right? What happens after x is greater than 255? We don't know, right? Until we look at it. And we have the ability at looking behind the scenes using this print function. And this is something we'll go over in the exercises as well. Print is a way to utilize the console that's there at the bottom. We've been looking at this console thing that's been blank pretty much, right? Well, if we actually use this function called print and we put some values in there that we want to be printing, this will just continually keep printing wherever, if the code is going over it, right? If this is inside draw and draw is looping, we're gonna be able to have that spit out at the bottom. So you can see that it's constantly updating. X is gaining one value each time. So after x is 255, it's just going to go to 256 and onward. It's just going to keep going. The white won't get any whiter, but the number will keep going. So in that instance, if we wanted X to do something once it reaches there, right, we would just have to set up a new conditional. Like if X is equal to a certain number, then we could do something else. So this is the kind of examples that we're going to be getting into with our exercises, so that we make sure we can grasp what's going on. So I did mention two equal signs. That is equivalent to, right? You're checking the value of one thing to another. But we can also use greater than, less than, or with equal signs. So these are all what they refer to as rational expressions. One equal sign is not a rational expression. It's a way to assign a value to a variable or a floating value or what have you. And then we also have some operators. So these are going to be really helpful to make your code a little bit more concise. So I really don't think that any of you really need to be using these. You could probably get around not using them, but they do help out quite a bit. They can make your code a lot more concise. So we will go over a couple examples of these. Primarily, like the easy example is location. So if you wanted to have a button in the middle of your grid somewhere, you want to know your X has to be greater than a certain value to be over that button, but also less than a certain value, right? Same with your Y values. So rather than having 4 if conditional statements where you say if Y is greater than this, then another one that says if Y is less than this, you can have them all in the same if statement and then just include 2 ampersands to add additional conditions in that one conditional. So we'll talk more about that. So transformations, these are different things you could also explore right on the P5 website, go through examples and play with them. I will note that rotate does end up being a little funky. So if you do want to be rotating stuff, you'll have to let me know, but so I can help you out. But primarily, the biggest thing you'll need for that is, I guess you could really use it for any of these three, is push pop. And you could just search the P5 for push or pop, and it'll go over that. There's not many people that end up using it, so I'll do a case-by-case basis on that. Translate is a way to like move the origin from the top left corner to somewhere else. So there's some instances where that could be useful. We already covered RGB stuff. You could change the color, the color space, but it's unnecessary. And as we said, the fourth number that you can add to an RGB, so it's four characters, is an alpha channel. And quite frankly, the alpha is like super undervalued, underappreciated, or overlooked for, I'd say, like well over 95% of my student projects. Jesus, my dog's out there freaking out. So if I were you guys, I'd be considering like, okay, I'm moving stuff around. Well, does it have to be completely solid, right? And especially if you're getting into abstract or explorative works, or anything moving around, definitely play with the transparency. So like similar to how we were in Photoshop and you were able to blend images together, you could bring images in here and move them around while blending, right? Actively in real time. So definitely like a really simple way to expand what you can do. A lot more with not very much code, one extra digit. So we've already talked about mouse X and mouse Y data, but we also have information about clicking. Same thing with keyboard presses. So this will be really helpful once we get into the tutorial about being able to select your objects, or what more accurately, like what location that these objects are on, unless you're kind of more advanced with code. Same thing with keyboard stuff. A bunch more related things here. So I did mention the display on draw keeps looping. I don't know if it's 60 frames or not. I know that's for processing. But you could actually change the frame rate by calling frame rate. You can actually stop draw from looping. I don't really know why you would do that, but there's probably some worthy instances once you get a little bit more advanced. Continuing here, almost wrapping up. So the cursor is another thing that's really underutilized. You have the ability of changing what it is you want the cursor to be. So you could actually add like little images to be your cursor instead of instead of a mouse pointer. You could have a hand or a crosshair, or literally just upload your own little thumbnail image and use that. So that could really enhance your project with like also not very much effort. This amount of code right here on screen is literally, if you go to this example on the website, the cursor example, each of those 4 quadrants is a different cursor. So that amount of code you see is for 4 different cursors. So man, they're going crazy out there. Continuing, I think that's about it here. Yeah, and this is just a repeat on that. Mention that the reference page for P5 is going to be like your best friend in terms of trying to figure out what to do and remembering what things are and how they work and how you can tweak them around. And what's really nice too, I think, is at the bottom of the reference pages, it also gives you similar types of code that you could, continue to kind of research further. So if I just pull this up real quick, we go to like reference, alpha. Let's go to alpha. It'll tell you what it is, description, parameters, and then nothing at the bottom, of course. Let's try fill. Description, parameters, alpha, value, gray, values. Let's also check rotate. So we have different things like angle and axis. So definitely going to be like your best friend. You can also kind of look into Coding Train, Daniel Schiffman's stuff. He does make it kind of fun. He's kind of like hard to watch, but it's not I don't think it's in a bad way. It's just a goofy way. So he's totally fun to watch, and follow along with. But a lot of stuff, honestly, if you're just really focusing on this tutorial that we're going to be doing, the 2 parts, and you save those and you have those for reference, that could be all you really need. So yeah, just make sure when you are coming to class these on Monday, and doing this video walkthrough, the part 1. Just make sure you're kind of keeping notes so we can make sure you understand what's going on. Cool. Thanks, guys.